I worked at Renault directly for Flavio Briatore. He was my line manager. He had an attention span of about 40 seconds. We'd been in a meeting with the senior management. He'd be saying something, and then he'd sort of run off into a mixture of almost Italian or sort of blurred speech, and then he'd walk out. We started our Flywheel business knowing we had to invent something that didn't exist.
Outside of sort of Lamborghinis and Audi R8, and it's vaguely the same engine, it's a very uncommon engine to have a V10 in either a race car or road car.
In Formula One, we didn't care whether it was a V8 or a V12 or a V22, frankly, and if it made more power, we'd have done it.
Ladies and gentlemen, welcome to all of the over 70 nations that are listening to the Wolfe Power Club podcast. Today, for the second time, we have a Formula One world champion on the podcast. So earlier on in the year, we had Emerson Fittipaldi talking to us about his predictions for the season ahead. But we're an energy podcast. And although a lot of the time we cover what energy we're going to supply and how we do it, we ultimately need engines that are going to take whatever fuel that we're discussing on Wolfe Podcasts to actually get the maximum out of it. Today, we have a man that, with his teammates, defeated Ferrari in their strongest period of Formula One history. He then used that technology in the adversity of redundancies to set up a KERS Flywheel company. Before then, thinking, I know what, let's convert a Rolls-Royce Phantom to electric power. Today, we have got Jon Hilton joining the podcast. Jon, how's it going I think you're based near Silverstone these days.
Yes, exactly. Yeah, so things are going well, thank you. And thanks for having us on the podcast this morning.
So, Jon, we're going to go back nearly 20 years now, and I know the story starts before then, but we want to get into the meat of what it was like, because this year marks 20 years since the R25, driven by Fernando Alonso, took both the driver's title and the constructor's title. And you can only win a constructor's title if the engine is working. What our listeners some will be jumping on it and know every race that happened that season. Others may have forgotten that between 1999 and 2004, Ferrari won every constructors in their period of dominance under Michael Schumacher and the likes of Ross Brawn and Jean Todt as a powerhouse. The year before, in 2004, Renault had a solid season, but it's fair to say you weren't competing for the title, and I think it was a top four finish. And you'd then go on in 2005 and 2006 to have a V10 produced by you and your colleagues that would end up bringing Renault 2 world titles, Fernando Alonso 2 world titles, and you could argue you're the only engineer that understood him because he hasn't won a world title since. And we then see that era of the V10 Renault with spectacular performance but very close margins. I think if I look at the results in 2005 and 2006, one failure, one missed opportunity would have lost the constructor's position. It literally was one race result in it between yourselves and the team that came second each year. So how did the engine team approach 2005? Because as said, Renault had been a solid team, but not a world championship team in the previous 6 seasons.
Yeah, thank you. Well, first of all, thanks for reminding me it was 20 years ago. And it's half a working life ago. I think the first half of my working life was all in engines. And it was a fantastic time. And I have to say that weekend we won the title in 2005, I'll always remember. It was spectacular. And from our side, as you say, it was so very close that, in fact, the engine we won that world title with, so it was a 17 race season, if you might remember, and the engine had to do 2 race weekends. We worked out really early on that if everything went to plan, you were going to have a single race engine for the last race that only had to do 1 race. And so everything we put on the dyno all year that lasted more than 1 race distance but didn't do 2, we put it in a box and said fit it for the last race. And then when we dug all these bits out and we put them in the last race engine, it had a really big step in performance for the last race. And we were gobsmacked. Nobody else had done this. I mean, some of them had got out of sync, so they couldn't do it. But quite a few of them were in sync and just hadn't done it. And it was a 35 horsepower step. And our race engineer, Pat Simmons, hid it from the rest of the world by running the car heavy all weekend until quali. And McLaren, who were very close to us in the title race, they honestly believed that they'd heard the rumour of the one race engine. They honestly believed there was nothing in it. And they believed we qualified on silly light fuel. But actually, in the race, we ran and ran and ran until they realised we'd had them, literally hidden this extra performance. And when it came out, we ran away and won, which was particularly pleasing, to have pulled it off with a clever stunt, basically. But I mean, I joined Renault in 2003, start of 2003 season, and I came from a very different place that had a very different engine. And so the engine I was used to was small and light, and it had very low friction, and the final power output was good. In fact, almost exactly the same as the Renault, but the Renault was big and heavy and had high heat rejection to water and oil. And so basically we spent 2 seasons, 2003, 2004, getting all of those low friction, smaller, lighter things into the Renault. And it took quite a long time because some of them were big structural changes, main bearing sizes, size changes, crankcase changes, big things. But when we got them all in, we managed to keep the high indicated mean effective pressure of the Renault, with the low friction of the engine that I'd been working on before, and that delivered a higher power output with lower heat rejection to water and oil and less aero drag in the car because the radiators were smaller, and it gave us a winning package. And I think particularly, I was based in the Enstone factory at Renault in Oxford, and the car chief engineer, Tim Densham, was a really good guy. And, we used to discuss what happens if I save 5 kilos on engine weight. And he said, no, just make me more power. And I said, no, don't be silly. 5 kilos in engine weight is important, we tackled a range of different things that hadn't been on their agenda. And that there were lots of areas where the Renault was excellent. It had fantastic air breathing performance and had fantastic RPM. As I say, really, really competitive IMEP, but it had lots of friction and lots of heat rejection, and those were the things we fixed.
And in terms of like the engine itself, because it's a real rarity today, whether it's race cars or road cars, it was a V10. Why are V10s so rare? And there must be quite a bit of complication with that many moving parts in a V10, because I guess for cost reasons and environmental reasons they've gone to this hybrid, smaller sort of type engine. But what were the sort of challenges of a V10? Because outside of sort of Lamborghinis and Audi R8, and it's vaguely the same engine, it's a very uncommon engine to have a V10 in either a race car or road car. So what puts engineers off the V10?
Well, it's not got proper secondary balance, which I guess would make it makes it a tricky thing for a road car. And I've owned a Lamborghini V10, and what a lovely thing! Makes a lovely noise. Yeah. It's got that beautiful flat engine tone that only a V10 makes, which is all valve gear noise, by the way. If you heard the cylinder head rig running electrically powered, it sounds just like the full V10. It's not exhaust noise or intake. It's all valve gear. But yeah, in Formula One, we didn't care whether it was a V8 or a V12 or a V22, frankly. And if it made more power, we'd have done it. But it's a compromise of you want, valve area in the piston. You can't run a piston bigger than a certain size or weight because you can't get the revs. There was no rev limit at that time, so the faster you could rev it, the more air you could breathe, the more fuel you could burn, the more power you could make. and nobody cared about fuel consumption in quite the way they do now, except that there was a limit on fuel tank size. But yeah, so it was about getting, well, a V12 could rev higher and had more piston to valve area, but it had more friction. A V8 was a struggle to rev to the right RPM because the pistons ended up very big, and a V10 just sat in the middle.
Nice. Now, as you alluded to, Renault was certainly the World Championship winning year, but your career had stints at other parts of the Formula One industry and engine performance industry. One part I was interested in was you at TWR, which very, very much was, and I remember as a teenager that I think they'd just signed Damon Hill, and they had a big open day at their Oxfordshire site. So I was probably one of those teenagers with a Hill T-shirt and a flyer or a photo out or a cap out to get signed by Damon. But I remember Tom Walkinshaw was a sort of great entrepreneur type figure, but it's fair to say I think TWR always had financial challenges. I never forget the Autosports story as a teenager, reading they'd been courting some prince from Africa who turned out to have no money and was very different from a sort of, and although Tom obviously won world championships in sports cars and stuff, it obviously F1 wise was very much a mid-table team, had pay drivers, and I was just wondering, what's the fundamental difference between being in a team that's almost fighting for survival or mid-table's a good result versus a team that's going for a race win every weekend? Like, engineering wise, was there much difference, or is it sort of right time, right place sometimes?
Yeah, I mean, so as you're right, TWR, I think for a long time, I'm not sure if they still are, they were the team that had competed in the most races without ever winning one. And they came really close with Damon Hill, didn't they? He finished second once. He had a throttle position sensor failure. That was the year before I joined, actually. So that 97, that would have been. So I joined there in 98. Yeah, I mean, the difference was enormous between there and Renault. I mean, at Renault, we had 375 people working on the engine. At TWR, we had 17. And so, when you're part of a small team, everybody has to pull their weight. Everybody has to, do long hours, do whatever's needed, fill lots of different roles. At Renault, we had one person who only ever designed pistons. That was all he ever did. At TWR, the same person did every rotating and reciprocating part, plus all the cam drive stuff up the front of the engine, plus the front cover, plus the oil pump. We did the whole engine with 5 people, in design. So, it was very different. And I think, we had to find ways of saving money, without affecting performance. Things like we used to make the cylinder head from both left and right hand cylinder head with just one casting, with the sort of front of the right hand on one end and the front of the left hand on the other end, and you machined off the one you didn't want, but it doesn't affect performance really. And it's a tiny bit of weight and, but it helps save money. I think my biggest tip, I'd say, if you were sort of David fighting Goliath, is that one of my personal sayings, the fastest way to do something is not do it at all. And so to get things done in less time and for less money, you just need to leave out steps altogether. Just put a line through them. Don't try, just look at it and say, well, I haven't got the money for that. I'm just not going to do it at all. And so things like computer analysis is a good case in point. In Renault, they analysed everything to death. Every component had stress and finite element analysis done on it. At TWR, we only did, I think, the crank, the piston, maybe the finger follower. I think that was it. 3 bits. And everything else, I looked at it, and went, no, that looks fine. Make it. And, I only got that wrong on about 3 or 4 bits. And you make a second go and you run again, but it cuts so much time and effort out of the process, and as long as the return loop to revisit it is quick, it really doesn't cost you anything.
how did you find it on a human level? Because there's one thing being a great engineer, and we'll go into a bit about your background, about sort of where that came from. But one of the stats that blows my mind, I went to a talk by Jackie Stewart and Damon Hill, and they were sort of saying that when Jackie Stewart won the world title, there was 12 people in the team, including his wife, who's got the stopwatch at Pitside.
Yep.
I think when Hill won the title in '96, there was around about 180 people in the team. And now when Max Verstappen wins, depending which rule you're following, but it's approximately 1,200 people, depending on who's working on the road car division. So going from like a team of 17...
Renault was about 875 in 2005,
so going from like 17 at TWR on the engine team, where, let's be honest, you can fit around 2 tables in a pub, to suddenly 375, where you...
And we did every Friday afternoon.
How did you find that on a human level? Because it's quite easy having accountability with 17. I can imagine it's much harder with 375 people.
Yeah, I think the very big team makes a lot of things more difficult. It's not always better. There's lots of areas where I found that very big scale hard. I didn't like it. It felt to me like there were huge swathes of people who... we ran an ERP system, and we had about 30 people who only fed the computer information. What's this got to do with Formula One? It's... I didn't... I understood what they did, and it was an important thing to control the logistics of such a big organisation, but it felt wasteful, and I didn't like that about F1.
Now, sort of in the area of F1, but kind of you followed a quite what I'd call almost classic British route to F1, in that started off in the aerospace industry with Rolls-Royce, and then you're picked up by Cosworth. And for our international listeners who are more energy experts than engine experts, Cosworth are probably the name in British automotive for engines. To date, they've won 176 F1 Grand Prix, and all the way, over the last 60 years, they've been involved in high performance engines, and in the modern day, they do provide the hypercar engines for the Gordon Murray and the Aston Martin Valkyrie. What would you say were the learnings from Cosworth? Because it's almost kind of a mythical name for us in the industry. I was fortunate enough to meet some of the guys, because they won an RAC award last year for the engine side. But what was it like, both joining Cosworth, and obviously you'd come from Rolls-Royce? What was it like, and what did you learn at Cosworth? Because I can imagine it's kind of a sort of DNA of most people I've met that have been successful in performance engines seem to have done a stint at Cosworth at some point in their career.
Yeah, absolutely. So, well, you probably met Bruce Wood, who's the current managing director, and Bruce used to sit 2 drawing boards down from me in the drawing office, so we know each other really well. And Cosworth is a fabulous place. Always was. I'm sure it still is. When I joined in March '91, Keith Duckworth and Mike Costin had recently retired, but they were still popping in. Keith still acted like he owned it, even though he didn't. But their legacy, you could see it all over the business. It was about efficiency, Mike Costin on the manufacturing side in particular, and Keith on the design side. But they had a system for everything. And back in those days, of course, paper-based. It wasn't even an Excel spreadsheet. It was a piece of paper that you wrote things on. But they had a proper system that stopped you making silly mistakes. And wherever I went, I took a load of those systems with me. And, when we got computers, you computerized them. But, as an example of the sort of thing, which it sounds mundane, but when you put a piece of work outside to an outside supplier, you used to print a copy of the drawing, and the drawing was, pencil on paper. You print a full-size A0 copy of the drawing, and you send it out with an order, to the supplier who's going to make it. And then if there was any discussion about, changes to anything on the drawing, something they needed to change to be able to make it more easily, you'd write it on the drawing in red pen and sign it. And then when the part came back in, it went to the inspection department at Cosworth with the marked up drawing. They checked it against the marked up drawing, all got passed through. Then the drawing had come back to drawing office, and you'd update the drawing with all the things that had been red pen, so that issue 2 was now out. But what this meant was the supplier didn't keep a copy of the drawing, so they couldn't steal your IP and sell it to somebody else. And when you sent them that part to make again, they didn't dig out the program they made it from last time, because they hadn't got the drawing. You had to give them a new drawing. They opened the new one. They saw it was now issue 2. They checked all those other changes. So I tell you, the number of times I've seen people get asked to make issue 2, what they actually made was issue 1, because it was easier just to press, I made that part before, press the button, And that didn't happen at Cosworth, and it didn't happen because they had a really simple paper-based system. I'll tell you, loads of companies now don't have that protection,
It's funny you say that, actually, because last year I was a director of an AI company, and one of the biggest challenges that energy companies had was that whole protection of intellectual property, when obviously, and there's ways to do it, but as you say, sometimes it's one of the reasons I understand that the British voting system has stayed paper, is that actually security-wise, compliance-wise, as you say, it gives you actually sometimes that security and that factor. And as you said, they're the process that work. I've read somewhere else that also what you liked at Cosworth is you could be working on many different engines at the same time. Can you give us an example of like a period in your career where you might have been working on different engines? Because that must have been quite exciting as an engineer to be tinkering with different bits rather than just one block.
Absolutely, yes. It was really exciting. And I mean, I was lucky enough, I was chief engineer of the motorsport division of Cosworth for a while. And in that period, we were doing German touring cars with Opel, British touring cars with Ford Mondeo, secretly British touring cars with Opel. But John Dunn at Swindon was building them. We drew them, he built them. And we also did World Superbike with Aprilia through the winter when the touring car stuff was turned off. So we did the Aprilia RSV Miglia SP in 1996. So yeah, we had a wide variety of stuff, and that was really good because certain formula had different restrictions. They had different rev limits. They allowed you to focus on efficiency as well as RPM. And then, in fact, when I came through to be chief engineer of the Formula One program at Cosworth, they kind of lost sight of that. They'd been chasing RPM at the expense of efficiency, and I'd come from rev limited formula where efficiency was really important, and so we could put those two things together and make a big step, 100 horsepower step actually in a year, which was a big deal in 97.
It's it must have been great. I mean, that's real diversity, that, isn't it? From a touring car through to a motorbike. I mean, I mean, just size of equipment, where you house it, and so on. But I guess it's that kind of breadth of knowledge that probably, as you said, when you're in a massive team working on individual components, you never get to see that sort of overall helicopter approach of sort of engine design.
Yeah, I mean, it's fantastic having the opportunity to draw the first 2 lines on a blank sheet of paper as, the V angle, and, then the bore spacing and really start from nothing. And, I've had the opportunity to do that more times than the chief engineer of Ford, actually, who doesn't get to do that many actual blank sheets of paper.
Oh, that is incredible, John. It now goes on nicely to, you've already mentioned a few people, and some of these are assumptions of mine that just looking at your timelines and so on, but you worked with, and I'm going to use the word notorious here because yes, they are well respected and famous, but there is stories in other media sources about stuff they might have got up to, both business wise, sporting wise, and I think it's just the nature of competition. But I was just wondering, with our sort of 430,000 listeners a week and over 70 countries, if you can share any stories about either the late Tom Walkinshaw or your owner Flavio Briatore in the Renault days, or Pat Simmons, or some of the drivers, even whether they ever got involved or interested in engines, whether it's your Alonso's or Fisichellas, because I can imagine, as you just mentioned there, you kind of known everyone over the Cosworth years, and then obviously you had that time. Is there any stories you can share that will either shock our listeners or make them laugh?
Well, yeah, there's a few. I think the one I'd like to share, which in some ways, it sums up Formula One in many ways, but it also goes some way to explaining why I was happy to leave Formula One at the end. So I worked at Renault directly for Flavio Briatore. He was my line manager. He was pretty much absent, right? You know, I saw him once every 6 or 8 weeks. And he had an attention span of about 40 seconds. And so it was quite common for him to, you know, we'd been in a meeting with the senior management. He'd be saying something. He'd start the sentence and then he'd sort of run off into a mixture of almost Italian or sort of blurred speech, and then he'd walk out. And so I after a little while, I sussed what was going on here, and I'd say, brilliant. So Flav says we're doing this, this, and this. And they all went, did he? I went, yeah. And we went and did it. And when he came back, I didn't get in trouble, so I kept doing it. That worked brilliantly for me. But also one other story, which I say the key one is, so I'd come to Renault from somewhere that was much smaller, spent a huge amount less money, and I found some of the things at Renault rather wasteful. So, I mean, Renault was spending 115 million euros a year on the engine alone, and I'd been used to 11 million. So, you know, this was a very, very different kettle of fish. And I could see a load of things they were doing that were very, very poor value for money. And I went to Flav with an idea that, and I'd done a bit of homework and I got it all lined up, and I made a little presentation I could deliver in his 40 seconds. And I said, look, you know, I've got this plan. In about 3 years' time, it will save you 18 million euros a year that you can spend on making the car go faster. And he said, okay, John, you know, and I told him what the idea was briefly. And he said, okay, John, he said, will it make the car go faster on Sunday? And I said, no, Flav, it won't. He said, okay. He said, will it make the car go faster 2 weeks on Sunday? And I said, no, it won't. He said, then off. And that was it, honestly.
I love it. I absolutely.
and that is F1. It's an absolute laser tight focus on the thing that really matters, and nothing else at all.
And it's funny to see that he's still involved. He's back at Alpine now. I think everyone's rumor mill that if he's back at Alpine, they must be looking for a seller or something, because it's a fascinating thing that people never seem to leave really in F1. They might change teams or they might have breaks or so on, but it's obviously a very addictive environment to be around.
It is. To be fair to Flav, though, you know, he picked good people. He knew how to pick good people, and he trusted them to get on with it. And the reason why I hardly ever saw him was because my bit was going well. You know, I dare say if my bit was going badly, I'd have seen him every week. So he's not a bad boss, not at all.
While we're still on the F1 years, one bit that's fascinated me, and this is more Alex the fan, you know, unlike yourself, although I've been 20 years in the energy industry, I've always been fascinated by the technical side, and I guess because I'm not an engineer by heart, but one of the things that has changed massively in the time that I've watched F1, and I guess also changed from the time that you started at Cosworth to the time ending at Renault, was that I remember in the early 90s, literally engines, I mean, it's almost a running joke that a Ferrari would never finish a race. I mean, literally, my childhood memories were always a very upset Jean Alesi stuck on the side of a track, having blown up another engine. And it was almost like every race, however big your lead was, your engine could blow at any time. And I remember, like, desperately, as a massive Damon Hill fan, you know, he'd never won Monaco and his dad had won it like so many times, and suddenly you saw the Plume coming out in the year that he had a massive lead. Murray would obviously go into unbelievable storytelling mode about the plumes of smokes and he's on fire and the flames, and it's kind of one of the reasons people love F1. But these days, whether it's Formula One or whether it's Le Mans wet racing, you kind of don't seem to get really engine failures. Like, there's such a rarity, and yes, they do occasionally happen, but it's gone from almost happening to a quarter of the field every race to something that almost makes the highlight reels on a Netflix season review because it's so rare. What changed in engineering? Because I can imagine it's one of the most challenging things to have unbelievable high performance, but also reliability, because as we all know, a Toyota engine might go for 1,000,000 miles, but it's certainly not doing high performance. It's not stressing any of the parts. So I was just interested, what's changed in performance motorsport that has allowed the plumes of smoke happening to a quarter of the field no longer happens in the same way?
So this simple answer is, well, we threw money at it. But simply, back in the 90s and all the way up to, I'm trying to think, 97, 96, we had, so Cosworth ran water dynos, so they absorbed the power of the engine, but they couldn't motor the engine. And about 95, 96, we swapped over to running electric dynos that had a motoring function. And so they could properly simulate a real flying lap. Because when you get to the end of the straight and you lift off the throttle, the weight of the whole car is pushing the car forwards and the engine is being rotated by the momentum of the car. On the dyno, if you shut the throttle, especially with the minimum parasitic losses of a water brake, it just stops. I mean, like, bang, stops dead, And so you couldn't, until about that late 90s, simulate the overrun thing. And as soon as you could start doing that, they started getting more reliable because you could program this electric dyno with a simulated lap of whichever you thought was the most stressful race, Monza or maybe Spa. And you could run lap after lap after lap on the engine and make sure that it didn't break. And you could do this in controlled conditions repeatedly, and then you could fix the things that were going wrong. Now, I mean, it's worth saying at Renault, we ran the transient dyno with a brand new engine on it every week. And the engines were 225,000 euros, plus the cost of running the dyno and the fuel. And we did this every week in, week out. And the deal with this, we were trying to get more revs. And so we were running 250 more revs than the car was racing with. And we were seeing what broke. And we'd run and something would break, and we'd run another one exactly the same spec next week and it'd break again. And we run one exactly the same spec next week and it'd break again. Sometimes with something different, maybe not the same failure as the first time. Then fixes would start to come through for the first thing that broke, and then the second thing that would break, and then something else would break. And then, fixes would come through for that, and then it'd pass. And then it'd pass again the next week, and then you'd race with that spec, and you'd turn the revs up 250 and you'd blow it up next week. And so out of 52 engines in the year, if 6 of them survived, and you got 750 RPM gain, everybody was delighted. But this is enormously expensive. But that is one of the ways in which you can do it. It's hugely wasteful, but it works.
I think just before we move on from the F1 part of your life, obviously we're a fuel podcast. Early on in the season, I was very fortunate to break 217 miles per hour by putting 85% ethanol into Nissan GTR on a runway, and we worked with the likes of Litchfield, and we were looking at sort of remapping each run we did to build it up. I was just wondering, did you obviously sort of in the Renault times they've always had a close relationship with the likes of Total and Elf and the racing fuel side. Did you guys think a lot, because it was interesting that when we were doing these speed runs, it's all about almost the smoothness of fuel input and almost getting the most out of the engine without breaking the engine. Did you work a lot with the fuel guys, or was it almost this and how did that sort of relationship build with the fuel teams and performance engines?
No, we definitely did. I mean, so I went to the Elf Soleil's plant several times, and no, we definitely worked with them on long-term programs, and they had engines dedicated to only testing their stuff every month, several engines every month. And when you looked at their gains, their solid, genuine gains only from fuel and oil, I think they were over 7% performance over a period of years. But, they'd done a really solid job. 7% of 800 horsepower is more than 50. You wouldn't have been there without them.
Right. Now, it was a bit like it was earlier in the year. We also had an Olympic boxer who got a medal, and I think a lot of people are a bit like, "Oh, you're world champion. Life must be great. You're going to go off to the sunset." But I think, like most realities, like our Olympic champion, actually, Anthony actually had one of the most worst personal moments during the 2012 Olympics. Although he was winning his bronze medal, sadly his mother was very ill, and then he had various injuries. And when we did our pre-meeting, although different circumstances, it reminded me a bit of your story in that basically you were telling me that literally days after winning the 2006 world title, arguably you are then in the top group of engine engineers in the world. The reality is there's a rule change in Formula One. The department's made redundant, so rather than a sort of happy ever after, actually it's go back to the drawing board for Jon Hilton PLC rather than Renault Formula One or another. But what I was interested by is you obviously had a CV that was unbelievable at that point of time. I'm sure there was lots of people that would love to have got you into their engine divisions at either high performance engine companies or into other racing, either teams or different formulas across the world. But you took the brave decision of walking away from a salaried paycheck and actually becoming an engineering entrepreneur. And you co-founded with some of your former colleagues the Flybrid systems company. What made you do that? Because it must have been a nervous moment going from these years of working in different size firms, but essentially knowing that there'll be a paycheck each month, to suddenly you're self-employed, you're setting up your own company. What triggered that, other than the situation of redundancy around the end of the engine unit and the rule changes?
Sure. Well, so yeah, as you say, we won the title on a Sunday and we all got fired the following Friday. But to be fair, Renault were pretty good with that. I had a bonus that was non-contractual, and I got paid it without tax, which was helpful. And me and my design manager Doug Cross, who I started the Flybrid business with, we walked away with a big check, so it wasn't all bad. And I looked at, I had a brief think about the F1 world, and Doug and I sat down the pub and talked about what we were going to do, but I was disenchanted with Formula One, to be honest. They were so big and so wasteful, and it was only getting bigger and more wasteful. It wasn't getting smaller and less wasteful, and it did really grind with me. So I was pleased to return to a small business space where you were fully in control, where you could see everything, where you could have that meeting in the pub every Friday, and we did. In fact, we set up our working hours so that we all finished in the pub on Friday, and we had a lot of freedom. We could do all the things that were right, carrying over the very best things of the F1 engineering style, but losing all of the waste. It was a lovely opportunity to take everything we'd learned and start completely from scratch. And we had enough cash. We started with about, £320,000, I think we had in cash between us, which is a decent starting pot. It was never enough, of course, but for reasons I can explain. But yeah, but we had enough to have a proper go, and we built a proper company, and we had really good fun doing it.
And it's funny because it reminds me a little bit of my own career. Like, I've worked for energy companies with multi-billion-pound turnovers, and then I also have a few of my own businesses, myself, from children's nurseries to the podcast. There's both brilliant moments and there's brilliant pleasures, but there's also shocks, especially if you've gone from a team of 375. It's a bit like at the energy company. I was managing a few hundred. What did you find in those first couple of years, sort of like, 2007 to 2009, the biggest shocks and the biggest pleasures? Sounds like one of the pleasures might have been the Friday meeting in a Northamptonshire pub somewhere, but what were the biggest shocks and pleasures of being your own boss? Because it is quite a culture change, even if you've got, a sort of war chest to go at it. What did you find with those ups and downs in those first couple of years of being your own boss?
Well, I think the first big up came pretty quickly in that, well, we landed a job working for the Honda Formula One team very quickly after we started, about 14th week, I think. But in the first 12 weeks, we already had the technology working. And I have to say, we started our Flywheel business knowing we had to invent something that didn't exist. We were running a very, very high-speed flywheel, 65,500 RPM, mounted inside a vacuum, and there was no vacuum seal in the world that did more than 20,000 RPM at the time. And we looked at the problem and we said, yeah, but we haven't yet come across a problem we can't fix in 12 weeks. And so we backed ourselves to do that, and we were 130,000 quid in before we got to find out whether we knew how to do it. But in fact, we had 3 working solutions on the test rig running in 12 weeks. And that was a huge relief. I think on the other side, I think the thing we underestimated the most was probably the amount of cash reserves you need in a small business. It's pretty easy to calculate all the things you need to spend money on. We're maths people, aren't we? Engineers. We understand profit and loss. We know what we sold things for. We know what we have to make them for. All of that stuff's fine. The timing stuff is scary, and it becomes pretty difficult to sleep at night when you haven't got enough cash in the bank to pay the wage run at the end of the month, and you're waiting on customers paying big lumps of cash and you don't know if it's coming or not. I found those things psychologically the most difficult, especially as the business got bigger and the sums got bigger. When you need to find £120,000 a month to keep the doors open, and you've got about 240,000 in cash in the bank, 8 weeks money. It's a bit bloody tight for me.
It reminds me of my favourite fuel saying I was taught very, very early on. It's like, it's like volume is vanity in fuel. So you can sell 1 billion litres, but if you're making no money, you could be losing £1 billion. And it's then obviously margin is sanity, but I say cash is king. And I think it's even when I went to Britain's best business school and did my MBA at Manchester, the lecturer that took us aside and was like, everyone talks about EBITDA and ROCE and profit. Just focus on cash flow. Just focus on cash flow, and the rest will follow. Now, I'm really interested because obviously with your guys' background, you could have gone into a number of different things in the engineering space, but you decided to commercialize the Flywheel KERS technology. As you sort of implied there, you kind of had an idea, but it wasn't proven or the solution wasn't there. Why did you decide to commercialize Flywheel KERS technology? Because it's kind of the opposite of what most people do in a business, which is look at someone else's successful business and kind of shadow parts of it to have a nice life. You guys went really entrepreneurial, really to cutting edge. So how did the idea come about?
Well, so that rule change that made us all redundant, there were 2 rule changes. One was to homologate the engine so you couldn't change anything. In fact, turned out till 2014. And the other was to allow KERS. And the FIA, I'm sure they had imagined electric. But whilst we were still at Renault, we'd done a full review of everything there was out there. On Renault's ticket, we'd visited all the KERS manufacturers, all the electric KERS people. We'd looked at them all. Basically, Flavio said, I'm going to get KERS banned. We don't want it. And I said, will you let me look at it, at least as a backup? And he said, yeah, go on then. So Doug and I got to tour the world visiting Magneti Marelli and all the people who were building electric cars, and we saw everything they were doing, and we didn't like any of it. And we came up with our own idea for a mechanical KERS, and I pitched it to Flav and said, look, if KERS is coming, rather than making us redundant, let us do it for you in what used to be the old engine bit. It's a powertrain technology, right? It's got to be us. And he said, I'm going to get it banned. You're all fired. Fine. Absolutely fine. Whatever you like, mate. So we said, well, we've had this good idea. We think we know what we're doing. We've seen all the competitors. Let's have a go. And so, we done our research properly. We were really sure that it was, and I believe it still is, the most efficient round-trip storage method for short-term energy storage. The round-trip efficiency of our system was better than 70%, 71, 72, with some time and effort and development, you could have got it to 75. Maybe you could have got it to 80. Electric was about 50 at the time, about 50%. I'm sure they're making it better. They're not at 72. And I can tell you they're not at 72 because every time we watch, every time I sit and watch a Grand Prix weekend, you watch them in qualifying, go out on their fast quali lap, and they cannot do 2 consecutive laps at full speed because they have to do a load of battery preparation, which is code for the KERS system is so crap that it cannot store enough energy in 1 lap to refill the battery. Honestly, that is what it is. Every weekend, I look at it and think, what are you doing? A flywheel car could fill the flywheel. It was our design goal. It was the only thing that made any sense to us. We said, of course it has to fill the storage medium every lap. Nothing else works, And so, I mean, it's interesting to see 2026 because this effect it could be really, really enormous. The preparation thing might get really out of hand. I'm interested to see. I haven't tried to do any sums on it, but my gut feel says, they're pushing for so much releasable energy that you'll only be able to do it, really quite infrequently. And that's not a Formula One car for me. I think that's gone wrong. Flywheel cars should have a significant advantage. F1 has banned flywheels, by the way. When everyone had picked an electric solution, and as soon as Honda pulled out of F1, so ours never got to race, they quickly banned it so nobody would have to spend any money doing this. But it's a shame because it's a better technology.
And that leads us nicely in it. Now, obviously, we're an energy podcast, Jon, and I think certainly forms of KERS and kinetic energy recovery systems have been one of the big things that's gone from kind of elite sport into mainstream automotive, whether it's in cars or trucks and so on. What do you think long term is the energy demand reduction that it could have in our sort of society with, say, more standard vehicles implying more KERS technology? I appreciate you're no longer in the company, but do you see it as a route? Because everyone talks about energy transition, but a lot for me is always getting more efficient about what you do today. What do you think the opportunities still are for KERS in energy sort of utilization?
Well, I mean, particularly if you look at cars, and to give you a real world example, so when we put a KERS system in a Jaguar XF, and in the Jaguar, if you braked from 70 mile an hour to 0, stopped at red traffic light, say, and then launched the car using only the flywheel and the engine turned off, you could get it all the way back to 50 mile an hour before you had to turn the engine back on. That's how good it was. And, that makes a really big difference. But the truth is that most drive cycles haven't got that much braking in. Certainly the regulatory driving cycles, they're very gentle braking. Real world isn't really like that. One of the things that a good KERS system, a powerful one, does is closes the difference between aggressive drivers and gentle drivers. So, the aggressive driver who brakes late, brakes hard, and then accelerates hard on the other side of the stoppage, they waste energy to the brakes. But if your KERS is powerful enough to capture 70% of that braking and release it on the other side of that stop event, you don't have a very big fuel loss. So our KERS-equipped cars, what they did on the regulatory drive cycle was one thing, and the answer there is about 15% of the energy to drive the cycle was lost to the brakes. And so if you could capture all of that, we were getting 10 to 12% fuel efficiency saving just from KERS. There were some other clever things we could do with the flywheel that saved a bit more fuel, but 10 to 12% just from KERS. But a more aggressive driver might see that number being 30%.
Well, I used to employ 900 truck drivers, and it's fair to say we always got the data about who was slamming their brakes. So I think the boys we used to have chats with who were getting red KPIs, they would love to hear that actually they could have been a KERS champion. Then going on more to the sort of entrepreneurial side, then in 2014, after 7 years of sort of hard work, and you said those sleepless nights about how do we get to month end and so on, Total Track, where you came a non-exec at one point, decided to buy you out. Don't know if this figure's right, but it was in your old institution that they bought the company out for a reported 16 million. How did that feel for you and your co-founder in terms of not so much the money side, but I'm more interested that the idea that you guys had as you went around these manufacturers in your last year of Renault, suddenly 7 years later, employing a decent number of people, suddenly someone else in the industry who obviously has good business sense, has good engineering background, is like, there's some real value add in this company, and that's why I'm buying it. Like, how did that feel? Because that must have been quite a professional accolade in a kind of way that performance sport might give you trophies, but that's actually someone putting their money where their mouth is to say that actually the work that you and your team have done has a real value add in the engineering world. What was that feeling like, and how did it come about in terms of them looking to acquire you guys?
So, yeah, I mean, well, with the Flybrid business, we got to the point where we had a big list of customers. We had Volvo, Jaguar, JCB, Wrightbus, and the like. We had two of those customers who wanted to go to market, to production. But those two customers, they each had relatively small market shares in their market space, so less than 5%. And so one of the options was doing an exclusive deal with them so that they funded building a production facility and then we sold it only to them. But that didn't really make sense when they were so small in their market space. What really made sense was for us to build a production facility ourselves and to fund that with our own money so that we could then sell this same product to all of their competitors. So we actually went out looking for cash, and we were, offering for sale shares in the company to raise this money. And Total Track came to us as a potential buyer of those shares, but they said to us basically, we will buy this 30% of shares we were offering for sale, but only if you'll give us a right to buy the remainder, subject to us having a board. They had to have a vote, shareholder vote actually, to pass to be able to buy the remainder. And so we started discussing this, and we bartered on price, and your number is the final number that we achieved. And in the end they got to a number we were happy with, and we said yes, and they bought it. As you say, getting rewarded in pound notes is very different to getting not a trophy, actually, a picture of yourself holding the trophy, maybe, which is not really quite the same, is it? But yeah, no, it was a fantastic vindication, you know. I mean, it is worth saying that when we started Flybrid, our very first meeting was with an exit strategy planner. And so we built it from zero with an absolute target to sell it. We didn't think this was something we'd run forever, or it'd be a legacy thing we'd pass on to our children or anything like that. We discussed with this exit strategy planner what a £10 million business looked like, how big it was, how many people worked there, how many patents you needed, how many clients, what sort of turnover, all the other detailed things that he said, you know, everybody under contract, clear who owns the technology they develop. If you take on contractors, you need contractual terms where you own the IP, you know, all of this stuff before we touched anything. And then we just went and did the plan. You know, we broke it down into, okay, if we're going to get to there by the end of year 5, here's where we need to be year 1, here's year 2, here's year 3. And then we just did that. And we stuck amazingly well to the plan, but it really helps if you've got that focus in your head. So, you know, for example, we had to choose a CAD system at the beginning, and we were a small business. We had 3 members of staff at the beginning, but we knew we were going to be a 25-person, £2.5 million turnover business in a few years' time. So we chose CATIA. It's one of the most expensive CAD systems, but it's what all the car makers use, and it's the right answer in that space. And so we bit the bullet and we bought that, you know, first week. So, you know, what we really did was make a great plan and stick to it. And, you know, yes, we were 2 years late selling, but we overshot on money. So perfect result.
And I think that's a very good plan for people. Do you think, like, also that background in having to have engines ready for a start of a season, time frames are measured very clearly in years? Because kind of, I think sometimes I meet some business owners that say don't have quite that same success, and a little bit always feels down to that. As long as they can go on a nice holiday, cover the mortgage, pay the school fees, or, you know, whatever's important to them, it doesn't have that sort of same time pressure. But it almost feels like you and your business partner ran it like a competitive enterprise, that you had certain dates and things to hit from day one, and that's almost like the DNA of the two of you, that you can take the guys out of F1 but not that sort of a disciplined approach of timeline. Would you say that's one of the sort of key things you got from your previous career before going into running your own business?
I would. In fact, I'd say a couple of things there. So time is more important than money. Right. So whatever you can do to make the time shorter, even if you think you're small and you think you're short of money, spend the money, because overrunning on time ends up being enormously expensive. You know, it's the overheads of everything for those extra weeks. You don't get to start your next job on time. Everything else runs late. And so, I mean, we had a brilliant example. I'll share a funny story. So we had a KERS unit in a Ford prototype vehicle, and it was testing at Dunton, down in Essex. And on a Friday lunchtime, we had a phone call. Something's gone wrong. It stopped working and it's making an horrible noise. And we've got a director's drive day on Monday morning at 10 o'clock, you know. And look, just chill, calm down. And, you know, tell me what's happened. What were you doing? You know, okay, right. Start taking it out of the vehicle. We'll have a guy there in 2 hours, and we'll bring it home and we'll fix it. Don't cancel your Monday drive day. And he said, look, but you can't. I said, don't cancel it, you know. So we had this thing back, and we used to do a thing we called Plan B parts. So we'd finished the design of the thing, and we put everything into manufacture. And during that sort of lull, when the design was finished but before the bits turned up, we'd go into the meeting room with a group of us, you know, all the senior people, throw the CAD models up onto the big screen and walk through it, saying to everybody, point at something if you think it looks like a likely failure point. You know, if you were going to imagine where this was going to break, what do you think was going to go wrong? And we'd home in on 3, 4, 5 pieces that we thought, yeah, that maybe looks a bit skinny, or that's a bit of a sharp corner in that radius in there, or that casting's a bit thin, or whatever it was. All right, go away and design me the fix for if that went wrong. And, come back next week and I'll see all those bits. And so we came back next week, looked at those, and then we said, okay, great, make them and put them on the shelf. We're going to run your first one because we need to know if it works. But if it goes wrong, the bit to fix it's out on the shelf. So we brought this thing back from Ford. One of those things we guessed went wrong. We took it apart. We fitted the Plan B bit off the shelf. We rebuilt it over the weekend, tested it on Sunday, delivered it back to them. They had it fitted to the car. The Monday morning thing went perfectly. The director's drive day went perfect. And the big boss of Ford, Graham Hoare, he said to me, I heard what happened. He said, how the hell did you do that? And so I explained, and he was blown away.
I love it.
And they couldn't conceive this was something you could do, but of course you can.
John, I just wish you'd worked at Ferrari road cars in the late 80s, because I've got a Testarossa, and the other day an ECU ignition went, and a very simple part, but it was a very painful process, both time and finance-wise, to get it replaced. So I like that. So guys, if you learn anything from the Wolf Power Club today from John, have a plan B in advance and make the parts to be on the shelf. Now, when you sold the company, you were only 52 at the time, and as I think I might have alluded to in the pre-meeting, my father's a retired nuclear engineer, and I think it's fair to say one common DNA bit about engineers, even if they're different parts of engineering, they're terrible at relaxing, in that what I've normally found in engineers, and you can meet any type of engineer, they're not the type of person that's going to enjoy the beach for too long. They'll do a few trips, but they need a project. It's fair to say my father now has the world's most complicated summer house you've ever seen, but it's been a fantastic 3-year project. I was just interested, those then sort of bit of time afterwards, from running your own successful engineering time to retirement the first time round, how did you find that, not having those sort of challenges of trying to find a solution for Ford on Monday morning or so on, because you went on to do other projects, which suggests that you didn't deal with retirement that well the first time round. How did you find it going from sort of full on to then suddenly more of a non-executive hands-off approach?
Yeah, so that's very true. I mean, I always need a project, and I've got an amazing workshop. I've got welding, fabrication, lathes, and milling machines, and everything. So so yeah. I mean, when we sold Flybrid, I mean, I worked for the new owners for a few years, and I think most people who sell a business find this pretty frustrating. I started winding down my hours. I didn't like the direction some things were going. I didn't always agree with what they wanted to do, but it was theirs, and I was resigned to the fact it was theirs. It wasn't a problem. So I started winding down my hours until I eventually retired in, I think, 2016. And it was too soon. As you say, I was 52. All my friends were still working, so, I had no playmates. But, I did have at that time a volunteer role as president of the IMechE, which was taking up 2 or 3 days a week. But, when that finished in 2017, in May 17, I really needed something else to do. And yeah, I kept looking for little projects. I did odd bits and pieces there, but yeah, it wasn't till a bit later that something came up that, that got me back into proper work.
And then this next bit that got you back into proper work absolutely shocked me. And I'll tell you why, John. When you go to Clark Hub, mate, you either get people who love engines and hate electric, or love electric and will tell the engine people why they're not in the right place. I think from your career leading up to this point, I think it's fair to say down the pub, you're probably known as like the king of the V10. I mean, you'd won 2 world titles with a V10. You certainly knew how to put an engine together from your Cosworth and Renault days, and then obviously you'd been working on flywheels. But the bit that shocked me in our pre-meeting was that you said you have a real satisfaction about the efficiency of electric motors, about electric drive chains, and then the opportunity that came up was Lunaz, and you were telling me that on a flight you met this guy, he then pursues you, and you go from being the king of the V10 to suddenly getting a 1961 Rolls-Royce Phantom and making it the ultimate electric car with Lunaz. How did that happen? Because most people would say those two camps don't normally mix, but you are actually very excited about electric motors and drive chains, and almost that challenge of taking one of Britain's most iconic cars and turning it electric.
Yeah, so as you say, I sat next to David Lorenz, the founder of Lunaz, on an aircraft on a flight to Ibiza, actually going out to my then girlfriend's place, now wife. And yeah, I mean, first of all, it started with a business discussion. We sat next to each other. He tucked a Supercar Drivers Club magazine in the back of the seat in front, and I said, "Oh, I belong to that club. What have you got?" And we started chatting, and then he said he was looking at starting this electric classic car business. And he said, when we get home from holiday, I'll come and see you. So he brought his business plan, and I had a look and said, yeah, well, that won't work. So I spent a couple of weeks rewriting it, for free because I was bored. And I gave it back to him and he showed it to his investors, and they said yes. And he said, you got to come and help me do it. So I ended up, as you say, being managing director of the Lunaz business when it first started. But honestly, anything can follow that development process that you use in Formula One. So that's what we did. We collected together a small multidisciplinary team. We built an early prototype. We tested it thoroughly, and we launched that Lunaz business. And it turns out that electric things are actually, they're mechanical, right? They're all of the things that go wrong with electric cars are mechanical. All of the things that you can do to make them go better tomorrow are mechanical. And I mean, literally, as long as you connect the wires the right way around, the electrons never go the wrong way. So whether it's a circuit board with a dry solder joint, or it's it's an electric motor that hasn't got enough cooling, or it's a battery where the cross-sectional area of the copper conductor isn't big enough to transfer the amount of current. These are mechanical problems. They're not electrical problems. And, electric cars are getting better at such a fast rate because the things that have been hoarded by the electric guys have been exposed to the really experienced and clever mechanical guys who are fixing all of these mechanical problems.
And I think what I like then about the Lunaz story is, great, you got David Beckham and all this sort of stuff. But I think the bit I enjoyed most was actually, as I say, up until a week ago, we didn't know each other. So this is definitely me just going as, it wasn't Supercar Club driver, but I went with a few mates to Hampton Court, Concours d'Elegance. And for international listeners that don't know, it's one of the big car shows in Britain of like the most beautiful and exotic cars. And Lunaz had a stand, and I can't remember if it was the Phantom or if it's the Aston Martin, but I remember it was the most divisive stand at the show because you'd have some people, and I think in the notes I've put evil genius, because some people were like, these guys are totally evil. They're taking these wonderful British classic cars with Rolls-Royce engines and Aston Martin engines that people their whole youths have wanted to own. They're taking them out at the cost of hundreds of thousands of pounds, putting electric drive chains. But then the genius part was not just about energy transition, but any journalist that you read an article that's driven a Lunaz car, whether it was the XK120 or the Phantom, was like, this is great. It's a British classic car that doesn't break down. It's totally smooth. It's quick to 60 in sub 5 seconds. It really, really is a pleasure to be in. Whereas, let's be honest, if you've ever owned one of these beauties, you've normally got a story driving down to Goodwood that you're pulled over on the A road somewhere, rolling up your sleeves, or some noise starts and you're absolutely terrified what that noise means. And just for our listeners, we'll put a link to a Piston Heads article, which is a sort of fans forum, and you'll see the comments that some people love Jon's work and some people hate Jon's work. I was just wondering how you felt, Jon, because you must have known about it just from the circle of friends you were in, where I'm sure of some of them, the word just electric motor disgusted them, but others were like, he's onto something here. So how was that sort of that reaction? And whether it was Hampton Court or somewhere else, I'm sure you experienced it a lot in that first year that people got to find out about the company and what it was doing.
Do you know, I always loved meeting the skeptics. It was great fun. And you know, turning them round was a proper challenge sometimes. But I mean, I remember the Rolls-Royce Owners Club coming to us. They were on a car rally around the country, and they stopped at Lunaz for a day. And they had a whole day tour. We gave them lunch. And at the end of their visit, the guy who was sort of leading the tour got up to speak to all the sort of Lunaz staff who'd gathered round. And he said, do you know, he said, last night we stayed in a hotel down the road in the Cotswolds, and we were having a drink in the bar, and we all decided we were going to absolutely hate this place. And he said, we were so wrong. He said, you know, we've seen the quality of everything you're doing, the faithful restoration of the bodywork and the trim and the, we were retempering suspension springs and, you know, carrying over as much genuine, real Rolls-Royce stuff as we possibly could, with a painstaking amount of effort. And the cars were beautifully, beautifully engineered. And, you know, these guys got to drive the cars, and everybody who did, as you say, you found that it was amazingly close to the original experience of driving. You know, they're not entirely rattle free. They've got aero noise off the wing mirrors. They leak air around the door seals. But the heater worked, and the thing started first time, and they're smooth and quiet, and actually making them quite a bit heavier with a load of batteries improves the ride enormously. And worth bearing in mind about modern electric cars, it's one of the reasons why they're so good. The ride is fantastic because they're hugely heavy. You know, it used to only be Rolls-Royces and Bentleys that were that heavy. And there's a reason why they rode so well. You know, when the unsprung weight is a smaller proportion of the overall weight, the suspension performance is better. You know, and so, we fixed all those annoying, silly things about them, whether they had a weird steering geometry and we'd made a new steering arm that took away the bump steer, or all of that was just properly done. And no, it was really lovely meeting the skeptics, and it was pretty hard not to like them if you got up close and saw how it was done.
Yeah, and I had a similar thing. I mean, I've seen a few of the Lunaz cars, and you can't come away thinking there's not engineers who've put a lot of love, passion, and pride into the project. Sadly, it wasn't always good times at Lunaz, and sort of towards the end, political climate of a government U-turn. They brought the electric date forward to 2030. For our listeners, the man that did that, Michael Gove, who's now editor of The Spectator. We've teamed up with The Spectator, and I'll be co-chairing the Energy Summit with Michael. So I'm sure in September, when I get Michael on, we'll ask about his date change and then the flip-flop to 2035. You also had the economic pressures, the reality of a Lunaz car. You already start with a car in the hundreds of thousands, and then it needs hundreds of thousands of pounds of work. There's obviously a more commercial division in terms of the waste trucks, but the waste sector's very slow in doing any change that has cost, because they're normally locked into 15-year contracts. There's very little reward from going away from diesel, and we've had lots of stuff on that on the podcast about that. So unfortunately, I had to pause car production at that sort of time. You sort of left the business. That we can say that they have started again production. What was it like though from an entrepreneurial level when you saw the challenges of electrification? I mean, I've tried in sort of 30 seconds to sum up the bumps, but there would have been other stuff. But it really is, I would say, perhaps one of the most challenging parts of energy transition is there's not much consistency, funding or support for entrepreneurs. I was just sort of interested how you see it, because you've obviously had many successful things, but obviously that's a strain when you have to make people redundant or close down or pause production lines. How do you reflect on that time? Because it's not easy being an entrepreneur in energy transition.
So you're right, it's not easy. I mean, I don't really think we can blame the government because, whilst the headline date might have changed from 2030 to 2035, they didn't change the derogation. That is the percentage of cars that need to be electric by certain dates. So they haven't really moved the target very much. It's more an adoption issue. So, I mean, somewhere between 65 and 70% of houses in the UK have off-street parking and could charge their electric car at home. And something like, and 34% of UK households have 2 or more cars. So one of them could be electric and the other petrol, and that takes away all your range anxiety issues, surely. Yet it's less than 5% of cars on the road in the UK are electric. This is an adoption issue. And I see a load of silly comments like, when they get down to the same price as a petrol car, I'll buy one. Well, never. I mean, how do you think it's possible to make a battery the same price as an empty tin can that was your fuel tank? I mean, it's just stupid, isn't it? Of course it can't be done. It's never coming. If you're waiting for that, you'll wait forever. But of course, they're enormously cheaper to run, so they can be a sensible financial proposition, particularly if you buy second hand. And, I run an electric car as my second car. I think it's fantastic. It can do pretty much everything. I charge in public roughly once every 100 days. So, how good the charging infrastructure is doesn't really matter. And whenever I have used it, it works perfectly. Never had a problem at all ever. I think they're pretty amazing. I still love the sound and smell of a petrol car, and I've still got a Porsche 911. So, but the BMW iX3 my wife has is an amazing car. But this really is a challenge for entrepreneurs like Lunaz, because to make any money, you've got to make proper volume. And in the Lunaz cars business, 50 a year is a proper volume, and 50 is not too many, and you can find quite a few wealthy people. They haven't got a problem with that business. In the truck space, you really need to make 1,000 a year to get to a place where you can make money. So when we built the Lunaz trucks business, we built a factory that could make 1,000 a year. But then we found that the people we were talking to, all the big waste companies, they talked about it and they were interested in it, and they knew they were going to have to do it at some time. And all the local government operators, the local councils and the like, it is their biggest emission. And they know they have to do it. They've been told they have to do it by 2030, but they all think they're going to do it in Q4 2029. And of course, that's impossible. The capacity of the industry to make their trucks is such that it will take probably 10 years to make all those trucks. They needed to have started in 2020 to be ready in 2030. And it's just naive to imagine that it's possible to wait that late. But basically, we built this 1,000 truck facility. We had Biffa ordered, a starting number of trucks. But what they really wanted to do was run them in anger for a couple of years, make sure they were reliable and could do all the duty cycles they had in mind, then start swapping. But what do you do with your 1,000 truck factory for 2 years while it's sat empty? And during that period, the company went bust. And this is one of the really big and difficult challenges. It's very, very expensive to get through a hole like that.
I think you've hit the nail on the head. I'm very passionate in that most waste truck companies are ultimately funded by the taxpayer, whether it's you paying your local council tax, so on. I've always been passionate that if you want energy transition, you want technologies to work, cities need to, whether it's at national and local government level, need to actually have it as part of the T's and C's, because then all the other industries spring up, such as service agents, the skill set to do it, and that's how you get a city to change energy transitions. I've been banging on about it for about a decade from the energy side of point of view. It's good to hear the engineer has a very, very similar point of view. Hasn't been heard quite yet, but the more we get this podcast out, hopefully it will do. Obviously, I've taken way more time, but we've got a few questions left. But John, this is more sort of, you have had an incredible career. We didn't even touch on your year as mechanical engineers president. I had a feeling we'd run out of time when I was putting the questions together. But essentially, what would you tell either an 18-year-old Jon Hilton, or we have a lot of people who are either graduates, apprentices that listen to this podcast out of our 430,000, that I think would love to have a career in engineering, that, you know, they might not come a world champion like you did, or they might not be that sell the company, but they'd love a career where they're working on fascinating projects and delivering solutions. What would you have told an 18-year-old Jon Hilton? Now you can look back on a fantastic career of many highs and many nights, it sounds like, in Northampton pubs, scribbling things on a tissue paper as you guys argue about, will it be a flywheel that works or not?
So, well, as it happens, I've got a 22-year-old son, Oscar, who's currently studying mechanical engineering at the University of Sheffield. So, I've actually had this conversation recently with him. I mean, firstly, engineering is a huge field with so many different branches, you know, in chemical, medical, and marine engineering. You know, not only cars and automotive, but first of all, you need to find something that really excites you and you know, makes you want to get up every day, because you're going to spend a lot of hours doing this. And you know, I always felt so lucky. You know, I spent my life playing with somebody else's super expensive Meccano set. You know, and you should all be able to feel like this. It's a wonderful thing. So I'd massively encourage people into engineering, and it's well paid. You know, but my key advice, I think, is to work out what sort of person you are. So, you know, there are what you might call sort of geeky specialist engineers. You know, the ones who want, they're fascinated by a great depth of knowledge in a relatively narrow field of specialty. And they, you know, there are others who are more general engineers who want, you know, a wider range of subjects at a shallower depth. You know, and you can't do both, and you just need to work out who you are. The geeky sort of person, they would be better in a bigger business, in my view, where they're likely to get to play to their heart's content, you know, on someone else's supercomputer, solving computational fluid dynamics problems or whatever their specialist area is, and they'll find this fantastic. The more general engineers, I think, are better off in smaller businesses where you get to see a bigger piece of the pie, and you get to see more of the areas where each of those different disciplines interact, because it's kind of on the boundaries of the disciplines where most of the gains are. It's on the boundary of electrical and mechanical where all the gains are in electric cars. You know, it's on the boundary between all the different engineering subjects where the most improvement is coming. And so if you can look across a number of subject areas, you can look for those. So yeah, I work out who you are and pick a large or a small business that can, you know, give you access to the sort of work that turns you on, you know.
Definitely, I think that's a great advice, and certainly for everyone, if you're interested in career opportunities, there's two great events coming up later on this year. There's the British Motor Show at Farnborough, where there'll be a lot of OEMs if people want to see what's happening there, but also in the oil and gas sector, if you love engineering, up in Aberdeen. It's called Offshore Europe, first week of September. The podcast is going to be there. And if you think F1's exciting, automotive is exciting, certainly the upstream side of energy is also unbelievable. And if you want big kits of engineering and big budgets, they certainly have them. But now we've got our quick fire question. I know we're both chatters, John, so how quick it's going to be, I'm not sure, but we'll give it a go. John, what would, and we ask this to all of our guests, what would you invest time or money into in the energy sector, maybe looking at the automotive side of energy transition in 2025?
So yeah, I saw your question. I'd answer the other way around. I'd bet against hydrogen. So as an energy vector, it just doesn't make sense to me. So the round trip efficiency of making hydrogen from water and then burning it either in an engine or turning it back to electricity using a fuel cell, it's very poor. And so and no amount of money spent on this is going to fix that. So just don't go there. For me, that's a surefire loser.
In the press at the moment, we're always talking about growth. How can Britain get growth? What would you like the government to do in the next 12 months? I'm not saying forever, but in the next 12 months that could really help growth in British engineering?
So I'm actually working on this with the Silverstone Technology Cluster and their Vision 2035 piece of work. And my proposal is that we need more risky debt. So we need relatively sensible interest, not low, 7% interest, loans up to 40% of turnover, I would say, for any purpose that makes your business more efficient or improves turnover. So I think the government should back that, so that, because the banks won't lend money to these, risky bets.
I think we'll actually have a whole podcast on that, because I know as a business leader at the moment, getting money for almost what I call a very stable bricks and mortar business with a proven business model case, problem and need, has taken me months. Whereas, back in the day, it was a lot easier to get support. And I think it's a big one, at the moment, in terms of funding ideas is very, very hard. In a more sort of positive light, do you think still with it being an engineering entrepreneur in 2025, that might be an opportunity for someone to get financial success and become a millionaire? Or do you think those days are over? It's only big companies that can achieve success these days.
Absolutely, yes. Of course you can. Engineers are so very well placed to be entrepreneurs. They've obviously got their technical skills, but they've also got excellent math skills, so they understand all the accounting side of stuff, and profit and loss and all of that is easy. And they're fundamentally, they're very intelligent people who can understand all aspects of how the business works. So they're ideally placed to be entrepreneurs in any space.
And we talked in this episode about how one of the biggest challenges Lunaz had when you were there, and you see with waste companies. But we also asked them in the podcast a quick fire question about the public. And that's, what energy or engineering choices should the public make with their feet that actually could really, help progression? Because sometimes we need the public to come on board because they're ultimately the customer.
Yeah, I really approve of reducing waste, and particularly, I like the idea of flexible energy tariffs, for example. So I've got an Octopus flexible energy thing with a cheap rate for night electric, and my wife and I have moved all sorts of things over to running at night, washing machines and dishwashers and all this stuff, and it makes a really big difference, and it is helping smooth the pathway to wider use of electric cars by freeing up energy at the times of day when nobody wanted it. So no, I think that's a really easy thing, and it saves you a lot of money.
Now, final question, and can I really thank you for your time today, Jon, and last week. I definitely want to meet up in person, because I think we've got a similar weakness for kit. Just looking at your scenery behind you, and I know my personal choices, that it's fair to say my biggest weakness personally has always been cars. It looks like you've got some very fun bikes behind you, and as you mentioned and alluded to, you might have had some fun pieces of kit to drive in the past. But a question I've stolen from another podcast that I really like, though, is that if you had a 2-car garage and one vehicle was to sum up Jon Hilton, and one vehicle was to leave as legacy or inheritance to your family, what would those 2 cars be? And to give us an ending note of, in a mechanical form, the engineer, the world champion, the entrepreneur, the future setter. Who is the man that you are in 2 cars, in both personality and inheritance for the family?
Well, so I've been lucky to own a load of my childhood dream cars, but I'd say the very best one, and the one that sort of sums me up the most, was I had an AMG GT, and that was a fabulous car. I did 55,000 miles in it. Loved it, drove it to death. I think one journalist described it as a muscle car designed by the current Formula One world champions, which I think was a brilliant description. And that you could be a complete hooligan in it. You could drift it off every roundabout. I must have drifted it thousands and thousands of times. It used to eat rear tyres. But I never hit a curb with it because it was the electronics were unbelievably good. You could hold big sideways angles, but perfectly exactly where you wanted them to be. And just a little lift and it grips up. I mean, I could even drift it on and off the ramps on multi-story car parks, and I never hit anything. It was absolutely wonderful. So an AMG GT for me. And for a legacy car, I really like simple, small and light things. It's a shame to cart around loads of guff. And if you wanted a really contentious future podcast subject, I think cars are so full of crap, frankly, that we never use. I've carried around airbags for 720,000 miles in my life, and I've never used one. What a waste of fuel, right? But so for my legacy car, I'd like something really small and light. I love the old Lotuses, but my son's 6'2" and he'll never get in one. So I think I'd leave him a Mark 1 Golf GTI 1600. I think they're absolutely fabulous things. Simple, efficient, and surprisingly quick, even in modern traffic.
As a lovely note to end on. What a mind-blowing episode. I think we've covered, how you go from the aerospace industry to a mid-size F1 team, to winning world titles, to then using the disappointment of a rule change to set up your company and legacy, and then in retirement tinker away and turn a beautiful Phantom and get the naysayers at Rolls-Royce Club to actually say, that's a lovely bit of kit. So I think on that note, Jon, I'm really, really delighted you were able to give up your time today. And I've got to say, I've learned so much, and literally it's a shame we have to end it because I think I could be here for hours, but it sounds like if I'm to catch you, it needs to be a nice pub somewhere in Northamptonshire on a Friday night. Absolutely. And a napkin with some pencils. Thank you for your time today, Jon.
No trouble at all. Thank you very much.